Alright, so here we're talking about span, and we have four vectors here in R4, and we want to ask ourselves the question, do these four uh, vectors span R4? In other words, can I take linear combinations of these four vectors and somehow achieve every single possible vector that lives in R4? So we note that, first of all, this is worth checking out because R4 is a four-dimensional space and we have four vectors. If we had any fewer vectors, this would not be a possibility, right? But since we have four, there's some chance that I could piece these four together to uh, to make up all of R4, but it's no guarantee. And so what we want to do is once again rewrite as a vector equation to move us to a familiar space, and then from there ask ourselves the question, well, is it true? So first things first, let's go ahead and rewrite this as a vector equation. And so if we're asking whether or not this spans R4, what we're looking at is, for any vector v, right, any vector that lives in R4, I can somehow find an x1 and an x2 and an x3 and an x4 so that whenever I pick one of these v's, I can find these four corresponding coefficients so that this holds true. So this has a solution for every v hat in R4. And so that is our equivalent vector equation. So now we're moving on to the question of, well, is it true? And in order to see that, what we need to do is take the left-hand side of this vector equation here, throw it into a matrix, so here we go. And find its reduced row echelon form. So why don't we go ahead and do that? We're looking at a 4x4 matrix here, where our first row is 3, 3, minus 4, minus 10, minus 5, minus 3, minus 3, minus 3, 7, minus 5, 3, 2, 12, and our last row is going to be 0, 4, 4, 4. And when I work that out, what I see is my reduced row echelon form as follows. So 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1, 0, and then minus 2, 0, 1, 0. Alright, and so this is sort of a partially augmented matrix, right? I've so far suppressed this whole v vector part of this thing. But let's note that if we had included that, so I'm going to go ahead and just made an amendment. If we had instead included some values here, right, what we would have here would be corresponding values in this last column. And what we note is that what this is telling us is we could have picked the right A, B, C, and D so that whereas these first four columns might turn out this way, I can pick the last column in such a way so that this over here would be 1, right? So what this is telling us is that there is some vector out there, and I don't know what it is, but there is some vector out there that's somehow not a linear combination of these four things. It's the vector so that if I put it here and I took its reduced row echelon form, I would end up with a 1. So having said that, what we can conclude is that since the last row of the reduced row echelon form matrix is all zeros, these vectors do not span R4, right? There is some vector, this mystery vector here, which gives us a 1 in that final slot, which is not in the span. All right, thank you.